Number 47. When analyzing home prices in Denton, these are considered resistant to extreme values. So we have 1 mean, 2 median, 3 standard deviation, and 4 IQR. So this is something you would be introduced to in a statistics class, but I'm just going to give you a set of numbers, and we can use this set of numbers to kind of approximate these. So I'm just going to use the set from 1 to 8. My pen is struggling a little bit here. 6, 7, 8. Okay, so if we just have this set, the mean is just going to be the average. So if you add all the numbers 1 through 8, you're going to get 36. And then divided by 8, that's 4.5. Let's see, the median is going to be the number in the middle. And so looks like our two numbers in the middle are 4 and 5. And so the number in between these, between 4 and 5, is also going to be just 4.5. The standard deviation, so what the standard deviation is, it's just how far on average are numbers from the mean. So if you look at this, 1 is 3.5 away from the mean, away from 4.5. 2 is only 2.5 away. 3 is only 1.5 away. So basically the idea is they're pretty close to the mean. So I'm just going to say the standard deviation, for the sake of the problem, we'll just say it's small, because it's a little bit annoying to calculate. Then for the IQR, this is what you do. You divide the set in half down the middle. So you can think of it as through the median. And then you find the median of the left and the right, and then you find the distance between those. So the first quartile will be the median of 1, 2, 3, 4, which will just be 2.5. And then the median of 5, 6, 7, 8 will just be 6.5. And so the interquartile range will be 4. So now let's see what happens if we add an extreme value. So I'm just going to take this list of 1, 2, 3, 4, 5, 6, 7, 8, and I'm going to add an extreme value. Let's just say 100. So for our mean, if we add all these numbers up, we already know 1 to 8 is 36, plus 100 is 136. 136 divided by 9, let's see, that's going to be 15.1. So already it's looking like the mean it reacts pretty heavily to the extreme value. We've almost tripled, actually we've over tripled our mean from the original setting. So for our median, so it looks like this is not going to be resistant. Not resistant. Then for the median, we're still just finding the middle number. So if you have 9 numbers, then the 5th number will be the median. And it looks like the number in the middle in this case is just going to be 5. So as far as the medians go, we jump from 4.5 to 5. So that's a pretty small jump, so I'm going to say that is resistant. And then for our standard deviation, our mean is 15.1. And so now our numbers are much further from the standard, our numbers are much further from the mean than they were. So like before, all of our numbers were like 1, 2, 3 away from the mean. And now, like 1 is like 14 away, 5 is 10 away, 100 is like 85 away. So our standard deviation is going to be much bigger. Much bigger. And so I'm going to say this is not resistant to extreme values. And then finally for our IQR, if we divide this down the middle, so we already have a true median. So I'm going to, when I divide it down the middle, I'm just not going to include 5. So let's see, for the left-hand side, we have 1, 2, 3, 4. So the median of that will just be halfway between 2 and 3, which is 2.5. And then for the right-hand side, 6, 7, 8, 100, our median is just going to be the number halfway between 7 and 8, which is 7.5. Now, the distance between 2.5 and 7.5 is just 5. And so our IQR, while it did increase, it only increased by 1. And so this looks like the IQR is going to be resistant to extreme values. So let's see. So it's resistant for the median, and for the IQR. And it looks like that is answer choice D. Alright, so if you have any questions from other tests, make sure to leave a comment and I'll make a video with the solution. With that said, if you enjoyed the video, leave a like and subscribe. This has been Investigative Math, and I'll see you next time.